morning, everyone. My name is G. Shankar Varma, Assistant Professor of EC Department, Marri Laxman Reddy Institute of Technology and Management. So now I am going to teach about the subject called Electronic Devices and Circuits. It is a fundamental subject for ECE students. So coming to the presentation, it consists of course objectives, course outcomes, course syllabus, introduction to the subject, PN junction diode, biasing of PN junction diode, VI characteristics of PN junction diode, and various applications of PN junction diode. So coming to the course objectives, what the students will be able to learn from this subject, that is course objectives. So the students will be able to introduce components such as PN diodes or various special purpose diodes, BJT, that means bipolar junction transistors, and FETs, field effect transistors. To know the applications of semiconductor devices and to study the special purpose semiconductor devices, to give understanding of various types of amplifier circuits, to design and analyze different small signal amplifier circuits. What will be the course outcomes from this subject? After learning this subject, student will be able to list the characteristics of various semiconductor components, understanding the utilization of components, analyzing the bias techniques, design and analyze small signal amplifier circuits, and demonstrate the BJT amplifiers operation. So these are the concepts student will be able to learn after completion of this course. Coming to the curriculum of electronic device and circuit subject, totally it consists of 5 units. In that, the first unit consists of basic PN junction diode and its applications. So the topics called like operation and characteristics of PN junction diode, static and dynamic resistance of PN junction diode, different kinds of capacitances, and the diode configurations. So these are all the PN junction diode fundamentals. After that, application part consists of rectifiers, filters, clippers, and clampers. So that's all about unit 1 and topics. Coming to the unit 2, we are going to learn about basics of transistor and different configurations. So actually the transistors is of 2 types. One is a bipolar junction transistor and second one is the field effect transistor. So in the second unit, students is going to learn about bipolar junction transistor. In the third unit, students are going to learn about the field effect transistor. So mainly the second and third unit consists of different biasing techniques of BJT, different configurations of BJT in the unit 2. Coming to the third unit, what were the different configurations and characteristics of field effect transistor, as well as the biasing techniques of field effect transistors. So again, the field effect transistors is of 2 types, that is junction field effect transistors and metal oxide semiconductor field effect transistors. So completely about the FET we are going to learn in unit 3. So coming to the fourth unit, the fourth unit is the analysis and design of small signal low frequency BJT amplifiers. So it is all about the small signal modeling of bipolar junction transistor. See, for example, if we want to purchase a BJT, maybe any configuration like common base, common emitter, common collector, based on which parameters we are going to choose a particular common base configuration or common emitter configuration or common collector configuration. Some typical values will be there for different parameters like current gain, voltage gain, input impedance, output impedance, etc. So based on those values, we are going to purchase different configurations. What will be the values, what will be the characteristics, in which way we need to choose a particular BJT, that we will learn in unit 4. So coming to the last unit, fifth unit, that is special purpose devices. So apart from the PN junction diode, several diodes are there having various applications and various purpose. So those are Zener diode. It will be used as voltage regulator, and SCR means silicon control rectifier, mainly used for switching purpose, and photodiode, that is also used for high switching purpose, and varactor diode. Varactor diode means it is used in tuning circuits and all, like general FM radios and TV receivers, etc. So apart from this, tunnel diode will be there, again a high switching diode, LED, solar cell, their operations and applications. Coming to the textbooks, here we have referred 2 textbooks. Those are Millman-Hawkins and the second one is Boylsted. Coming to the reference books, here we have highlighted 3 reference books. Student may refer any of these textbook as well as the reference. So coming to the introduction part, so here I want to highlight about the semiconductor material. So we know that the semiconductor material consists of electrical conductivity between a conductor and an insulator. So before going to learn about a semiconductor, just we will try to recollect basic definitions of conductor and insulator. So conductor is a kind of material which allows current through it or electricity through it. The best example is a copper wire. So insulator is nothing but a material which works opposite to the conductor. So it does not allow any electricity or current flow through it. Best example is wood and glass, etc. Rubber also the best examples for insulator. But coming to the semiconductor, based on certain conditions, sometimes it will work as a conductor or sometimes it will work as an insulator. For example, if we consider PN junction diode, what we are going to learn now, during forward bias, it will works as a conductor. That means like a switch in on state. For example, in certain conditions, the same PN junction diode acts as an insulator, like switch which is in off state, that we will see now. So some examples of semiconductors are silicon, germanium and gallium arsenide. Mostly silicon germanium is used for the manufacturing of PN junction diode, and this third example, that is gallium arsenide, is used to manufacture light emitting diode or LED. So here I have placed some images like mobile phone, laptop, LEDs, integrated circuit, solar panel, etc. In these devices, we are going to use different semiconductor materials, right? So those are the applications. So coming to the manufacturing of PN junction diode, how it is going to form and all. General symbol, if we see, it is having two terminals. One is anode and second one is cathode. So coming to the construction, so a P-type material, both N-type material chemically fabricated to form a PN junction diode. So the P-type material, we call it as anode part, and N-type material, we will call it as cathode part. So that is the basic structure of PN junction diode. So coming to the P-type material, how a P-type material is formed. The trivalent impurities such as boron or aluminum, we are going to add these impurities to either silicon or germanium to form a P-type material. So if you see this figure, if you observe this figure, by combining this boron or silicon to a germanium atom, if you observe carefully, these bondings are prepared and here one hole is formed, right? So in this way it will work. So coming to the N-type material, so here also semiconductor material like germanium or silicon has been doped with pentavalent impurities such as phosphorus or arsenic. So doping means nothing but adding impurities. So here also, if you observe this structure, entire figure, by adding impurities, here free electrons are formed, right, which will be helpful during the conduction. So coming into the brief note, the P-type material consists of majority carriers as holes, and electrons will also present but are very, very less. We call it as minority carriers. Coming to the N-type material, majority carriers are electrons, holes also present, but those are very, very less. We call it as minority carriers. So P-type is having holes as majority carriers. N-type material is consists of electrons as majority carriers. Coming to the biasing of PN diode, before going to see about the biasing of PN diode, what is the necessity of studying about the biasing of PN diode? Biasing is nothing but externally we are applying some voltage, right? Externally we are applying some voltage to the PN diode. If we won't apply any voltage to the PN diode, then we cannot use it or it won't work. If we make it work or if we want to utilize its application, we need to apply some external voltage to the PN junction diode. So that is called biasing. So PN junction diode biasing is of two types. One is forward bias and the second one is reverse bias. So biasing is nothing but applying voltage or connecting voltage to the PN diode. That is also DC voltage we are connecting. Generally a DC battery we will say, right? So first we will see forward bias. In the forward bias, we are going to connect p-type material to the positive polarity of the battery and n-type material to the negative polarity of the battery as shown in this figure. This battery acts as DC voltage. Initially, if we connect p-type material to the positive polarity of the battery or as well as negative polarity to the n-type material, and if we keep on increasing the forward voltage, then first of all, these charge carriers present in p-type material, that means holes present in p-type material, try to reach towards to the battery, as well as the majority carriers, nothing but electrons present in n-type material, try to reach towards to the negative polarity of the battery. As we all know that if like charges are there, they won't attract with each other, they will repel with each other. If opposite charges are there, attraction will happen. What we are saying, the p-type is majority carriers holes and they are having positive charge. And the n-type consists of electrons as majority carriers and it is having negative symbol. That means minus as its symbol. So here plus cannot attract towards to the plus and minus cannot attract towards to the minus. Then what will happen? The holes won't able to reach towards to the positive polarity of the battery and the holes present in p-type will move towards to the electrons present in n-type material. Okay, this process will happens like this. In the same way, the electrons consist of negative charge and they are unable to reach towards to the battery and will repel from the battery, and the only option is the electrons present in n-type material will recombine with the holes present in the p-type material. So by this recombination or the exchange of charge carriers from p-type to n-type as well as n-type to p-type, the current will flows across the diode, and in this way the conduction will takes place during the forward bias. And we can say in the forward bias only the p-n junction diode is in on state. So whatever we have discussed until here, that I have written in this slide. So in the forward bias, the p-type material is connected to the positive polarity of the battery and n-type is connected to the negative polarity of the battery. And one more thing, here we have discussed about the cut-in voltage or knee voltage. So let us assume we are considering a germanium semiconductor to prepare a p-n diode. Then the cut-in voltage or knee voltage is 0.3 volts. That means up to 0.2 to 0.3 volts. And let us assume we are considering a silicon semiconductor material to prepare a p-n junction diode. Then the cut-in voltage will be 0.6 to 0.7 volts. So after reaching the cut-in voltage, by applying a forward current, the forward current will increases exponentially. How it is going to increase, that we will see in the VA characteristics. In the forward bias condition, the current flow across the p-n diode is more and the resistance is less. We all know that there will be a relation between voltage, current and resistance. That is Ohm's law, V equal to IR, whatever I have written in the slide. Here in the third point, we are highlighting that in the forward bias condition, current flow across the p-n junction diode is more. That means if current is more, from this formula, what we can written? V by R. That means the relationship between current and resistance is inversely proportional. If current increases, resistance will become low. If current decreases, resistance will become high. That is the inversely proportional relation that we can observe from the Ohm's law. So that's all about the forward bias. Quickly we will once check the VI characteristics and later we will move to the reverse bias of p-n diode. So if you observe the VI characteristics forward bias, what happened here? If we keep on increasing the forward voltage, right, after reaching the knee voltage, what will happen? The forward current will increases exponentially. So coming to the reverse bias, in the reverse bias, p-type material is connected to opposite. The connection is opposite to the forward bias. Here p-type material is connected to negative polarity. In forward bias, what we have did? We have connected p-type material to positive polarity of battery. Here in reverse bias, we are connecting p-type material to negative polarity of the battery. And n-type is connected to the positive polarity of battery in reverse bias. There in forward bias, what we did, n-type material is connected to negative polarity of the battery. So reverse bias is nothing but here we are changing the polarities of the battery. Whatever we connected in forward bias, we are exactly connecting opposite to forward bias. So one point we discussed during forward bias, that is like charges will repel with each other, opposite charges will attract with each other. Based on that, if we observe the reverse bias condition, if we connect p-type material to negative polarity of battery and n-type material to positive polarity of battery, and by keep on increasing the reverse voltage, now we will see what will happen. Here the holes consist of positive charge present in p-type material will attract towards to the negative polarity of the battery in this way, and the electrons having negative charge present in the n-type material will attract towards to the positive polarity of the battery in this way. Here there is no recombination of charge carriers from p-type to n-type and n-type to p-type. If recombination is there, that is also very less. That is also due to minority carriers, but majority carriers will try to attract towards to the polarities of battery. By this action, the depletion region width will get increase. So here we have to observe one point. In forward bias, depletion region will becomes thin by keep on increasing the forward voltage. Why? Because the charge carriers will move from p-type to n-type as well as n-type to p-type. But in reverse bias, what will happen? The charge carriers present in p-type attract towards the negative polarity of battery, and the charge carriers present in n-type material will attract towards the positive polarity of the battery. That means due to this action, the width of depletion region will increases in reverse bias and it is widened. That is the point we have to observe. And one more point here, the current flow is very low. We can say there is almost no current flow. So by this action, what will happen? Resistance will get increased. That we have seen in forward bias based on the Ohm's law. So coming to the, again back to the VI characteristics of PN diode, we have already discussed about the forward bias. Coming to the reverse bias, what will happen? By keep on increasing the reverse voltage, the reverse current will be constant. But the thing is, in forward bias, forward current depends on forward voltage. But coming to the reverse bias, the reverse current does not depends on reverse voltage, it depends on temperature. For example, if the temperature changes, automatically reverse current will change. Remember this point. And if we keep on increasing the reverse voltage at a particular voltage called breakdown voltage, the device, the PN diode will get damaged and the current will flow abruptly as shown in the VI characteristics. Right. Coming to the application part of PN junction diode, that means where we are going to use this PN junction diode in practical scenario. First one is rectifiers. So what is a rectifier? The rectifier is an electronic device used to convert the pulsating AC to DC signal. So before going to tell you about the pulsating AC, DC, just I want to give you a small brief regarding this AC. AC means alternating current. Just I will draw the waveform. So based on time or frequency, the voltage is going to vary like this. From positive to negative, again it will alter. Negative to positive, positive to negative. It will continue like that. That's why we call this wave as alternating current. So one of the sine wave is the best example for AC signal. So next one is DC part. DC means direct current. It will be like this. Let us assume this is a 2-volt signal. It will flow in unidirectional, either positive side or negative side. So now what the rectifier will do? Rectifier takes the input as an alternating current and it will convert it into DC. But not pure DC, we call it as pulsating DC. Pulsating DC means it will be like that. So pulsating DC means consists of DC along with some part of AC or little bit of AC component will present. Later we will use filter to remove that AC part. So coming to the another application or second application, that is bipolar junction transistor and field effect transistor. So there will be, earlier we have seen during the discussion about the curriculum or syllabus, the transistor is divided into two types. One is bipolar junction transistor and the second one is the field effect transistor. So mainly the transistors will be used as amplifiers as well as switches. In the unit 2, we will see how the transistor will be used as amplifier, how the transistor will be used as switch. So next part is nonlinear wave shaping circuits. Clippers, both clippers and clampers comes under nonlinear wave shaping circuits. So coming to the clippers, it is an electronic circuit used to remove the unwanted portion from the input wave. So some portion, if maybe complete positive peak, if we won't need it, by using clipper we can remove it, or some portion from the positive side, or sometimes we won't utilize the negative part from the input, we can remove that negative part or some portion from the negative part. That we will see during unit 1 discussion. So that will be used in wave shaping circuits. Coming to the second one, clampers, an electronic circuit used to shift the entire waveform to DC level without changing its shape. DC level means, just now we have seen the complete wave will present either to positive side, either at negative side. Okay, it won't present some portion at positive, some portion at negative. Then it will become AC level. DC level means completely the wave has to shift to either positive level or negative level. So main application is DC restoration. Coming to the fifth application, that is light emitting diodes. It is a semiconductor device that emits light whenever a current flows through it. Best application is optical communication, as well as we can also say remote control. In our house, we will observe TV remote controls. In front of that remote, some small bulb will be there. That is the light emitting diode. What it will do is, actually it will convert the electrical energy into light form. So in our home, we use the TV remote. It consists of IR wave, infrared wave. So it is not in visible spectrum. That's why we won't able to see that light wave. What it will do, if we change the numbers to change the channel, it will pass that information to the TV. And the TV receiver consists of another small bulb will be there. That is not LED actually, that is photodiode. So during transmission, we can say like this, during transmission, LED will be there. And at the receiving side, photodiode will be there. So I will just draw the symbol of LED. So same, it seems like PN diode only, but the only thing is we will draw these arrows which indicates it is a light emitting diode. In the 5th unit, special purpose devices, we will study about these LEDs, photo devices, etc. Right? So those are the important applications of PN junction diode. I hope you understand about what is PN junction diode, biasing and its characteristics, and few examples or applications of PN diode. So in the further classes, we will see about the different components and different devices present in the syllabus, right? So that's all, and these are the few references that I have highlighted in this slide, some textbook names as well as NPTEL links. Through these links, we can refer the concepts. Thank you.